are not related to the atmosphere. On the other hand, the blue represents things such as hurricanes, tornadoes, droughts, wildfires, anything that is weather related. And then this red line represents the amount of economic damage that's being caused. Now, as you can see, from 1950 over to 2012, there has been a substantial increase in the amount of natural disasters that have occurred. Now, is that because our Earth is becoming more dangerous? Not quite. Here's why. As we have advanced technologically, things that we're able to do now, we couldn't do 10 years ago. Think about it. Right now, you're watching this video, likely taking a class that 10 years ago or 15, 20 years ago, you would have had to be in a classroom to take, right? Well, increasing technology has resulted in it being easier for people to report natural disasters. Plus, we have a bigger population, so more natural disasters are being noticed. And as I just mentioned, they're also being reported. As a result, that's why natural disaster occurrence seems to have increased. Okay, so is this climate change related? Well, if you compare the number of natural disasters increasing and you just look at the geophysical ones, so the earthquakes, the tsunamis, the things that aren't climate related, you notice that climate related natural disasters are still increasing more substantially than non-climate related disasters. If this whole increase was simply due to better technology and a higher population, these geophysical and climate related disasters, should be increasing at the same rate. But they're not. Climate related disasters are actually going up relative to geophysical disasters. As a result, I would argue that the jury's still out, that it's very possible that the increase in tornado occurrence, that the increase in hurricane occurrence, that the increase in the amount of dollars spent on economic damage, that each one of those things is actually due to a warmer climate. That each one of those things is potentially caused by climate change. But we still need to figure out why. Well, one reason why, and this is my argument, is remember what causes weather? Imbalance. This whole Earth is heated unevenly. And as it's heated unevenly, what you end up getting is weather forces that are designed specifically to even out the heat. Well, as you warm the Earth up, that actually creates even more imbalance. That creates more imbalance. Therefore, there's more energy that needs to be distributed. So it's basically like pouring fuel into a fire. And that means that we could see more storms and stronger storms. But again, the jury's still kind of out on this one. Now, what is for sure changing because of climate change? Well, we have noticed stronger hurricanes. We have noticed more heat waves. We have noticed more tornado outbreaks. And they're becoming more frequent. They're becoming more frequent. What else has changed? What about drought? Now, obviously, we're just recovering from the worst drought in California history. But even before that, the number of droughts on the west coast of the United States has been increasing over the past century. We've had lower lake levels we've had more water problems. Case in point, this is Lake Mead. Lake Mead is a major source of water for much of Southern California. Well, Lake Mead is substantially drier now than it was approximately 30 years ago. Now, what might be causing this? Well, one of the theories is what's called Hadley cell expansion. We've talked about Hadley cells before when we talked about global circulation. That was back in Module 6. So if you want to revisit that, go back to Module 6. But when we talked about that, we mentioned that there are these high pressure centers at 30 degrees north. Well, as the Earth is warming, it's believed that that Hadley cell is extending further to the poles. And so those high pressure systems are traveling further north and further south of the equator. That could result in additional drought. And another thing that is also potentially happening is as those Hadley cells are expanding, that's also taking many of those storm tracks, which come from the jet stream, which come from the polar front, and pushing that further north as well. So areas in the southern part of the United States are getting fewer storm systems reaching down to them. So that's one possible way that drought is happening. Now, what about sea level rise? I'm sure that many of you have heard, well, aren't sea levels rising? Yes. Now, there are two causes of sea level rise: thermal expansion and melting of ice. In the case of thermal expansion, the water, as it warms up, it becomes less dense. It takes up more space as a result, therefore that forces sea levels to rise. And then melting of land ice, when ice that's over land melts, all that water then dumps into the ocean, causing a rise in sea levels. Now, of these two, the biggest one, the most important one, is actually thermal expansion. Contrary to popular belief, it's not melting ice. It's actually thermal expansion. As the globe is on average warming up, this causes ocean waters to warm up. As these ocean waters warm up, they take up more space, resulting in sea level rise. Now, I'm a home brewer, and as a home brewer, one of the key things you do when you make a brew is you have to boil water. Well, if I want to boil a 1 gallon batch, I need at least a 2 gallon pot. Here's why. If I had a 1 gallon pot and I filled it all the way up, as the water heats up, it's going to take up more space. So essentially what happens is as the water heats up, it expands. And as it expands, the water level rises. So that's what thermal expansion is. And as I just mentioned, that is the key cause of sea level rise. Now, what about ice? Well, the poles have been warming up much more than the equator has. As a result, ice near the poles has begun melting rapidly. This causes a lot of problems. If you're a polar bear, you need that ice to live on. If the ice continues to melt, polar bears might become endangered. However, when we talk about melting of ice, we're not talking about melting of sea ice. Here's why. If you actually take a glass of water and put a few ice cubes in it, let those ice cubes melt, you'll notice that the water level doesn't rise. So when ice melts in a glass of water, the water level in that glass does not rise. So sea ice melt does not increase sea levels. However, when sea ice does melt, that does decrease the albedo of the Earth, which lets the Earth heat up more. That's a positive feedback mechanism. But what causes rising sea levels due to ice is land ice. So ice that's already melted in the ocean doesn't contribute to sea level rise. However, if you melt ice from land, the ice over land is not touching the water, not touching the ocean. But as soon as that water melts, as soon as that ice melts and it flows into the ocean, that does cause sea level rise. So again, the example that I mentioned, take 2 glasses of water, or take a glass of water, put some ice cubes in it, measure where the water level is, then let those ice cubes melt. And you'll notice that the water level does not increase. So again, write this down in red ink if you have to. Thermal expansion is what's causing sea level rise, and melting of land ice. Sea ice melt does not increase sea levels. But what is happening over land? Well, the most concerning place is Greenland. Greenland is what is thought to be a permanent ice shelf. However, as we've progressed over the last few decades, what we've actually noticed is that ice is becoming less and less common on Greenland. And during the summertime, more and more ice is melting. It is even believed that at some point in our life, Greenland could even be ice-free. Now, that's a worst-case scenario. If that were to happen, that would result in tremendous sea level rise. Because again, all of this ice is currently over land. It's not in the water. Once it melts, it then floods into the water. What will sea level rise do? Well, let's assume that all of Greenland were to melt. So all of the ice on Greenland were to melt, which is, as I mentioned, possible. And let's assume that that created 6 meters of sea level rise. That's about 20 feet of sea level rise. That's a big rise. So think about that. If you live near the beach, the ocean's now is now 20 feet higher. Most of southern Florida would be gone. Miami's gone. Lake Okeechobee's now part of the ocean. New Orleans is gone. Many coastal regions are gone. Even just 1 meter of sea level rise, this is relatively modest, could result in tremendous inundation, tremendous submerging of places. Much of New York City would be underwater. So, as the ocean becomes warmer and as land ice melts, that causes sea levels to rise. And as they rise, water's going to move in further and further on shore. Areas that are currently beachfront property are going to be submerged. And areas that were a few blocks inland are now going to be beachfront property. Imagine if you own a home just a few blocks away from the beach. What kind of a problem this could be. This is how California would look. And then this is more in the worst case scenario. So if all of Greenland were to melt and a good part of southern Antarctica were to melt, that could result in sea level rise of over 200 feet. In that case, the Central Valley would be completely underwater. And in that case, if you would like to travel to Southern California, can't take I-5 anymore, have to take 101. Here's how Los Angeles could potentially look after sea level rise. Again, this is worst case scenario. But this is how the whole LA basin could potentially look like after sea level rise. And just to add a joke to it, there are a bunch of funny names here. If you have time, I say pause and look at some of these and get a laugh. But it's also pretty serious. If we had a worst case scenario, 260 feet of sea level rise, practically all of the Los Angeles basin would be underwater. That would be a problem. And if that happens, many sharks may have more food. Now, the last thing I'm going to talk about before we wrap up this lecture is fact or fiction. So, I'm sure many of you have seen different movies such as The Day After Tomorrow, or Twister, or Into the Storm, or if you're bored and you're on Netflix and you're watching some of those horrible C-list movies, you've probably seen a lot of very sensationalist things. Well, with that said, there are many movies that actually do a really good job documenting climate change. Many that do a good job that address and document climate change. A few that I recommend, 6 Degrees Could Change the World. As I mentioned, if you are in my class, you're probably being assigned this. Then there's An Inconvenient Truth, Al Gore's movie. Other than the fact that Al Gore did it, I like the movie. I just don't like the fact that he did it because he's a politician. He's actually doing another one called An Inconvenient Sequel. And then many others. But then what about the sensationalized films? Well, let me give you an example of one. If you've ever watched The Day After Tomorrow, in The Day After Tomorrow, the thermohaline conveyor shuts down. And when the thermohaline conveyor shuts down, this causes the Earth to flip over into an ice age in a matter of a couple of weeks, and it's hurricane-like blizzards that do this. And LA is hit with tornado outbreaks, and there's all kinds of sensationalized stuff. Now, definitely abrupt changes could happen, you're not going to see this. And then other movies, Category 6 Day of Destruction, you can find this on Netflix if you want to. It's one of the worst weather movies in history. In this movie, hurricanes form from Arctic low pressure systems over the Great Lakes. Hurricanes are tropical, they don't form from Arctic low pressures. The Great Lakes, hurricanes don't form there either. So, very, very poorly done. But again, these movies are designed to entertain. They don't educate. But let me give one fact. In The Day After Tomorrow, they talk about something called the North Atlantic Current. The North Atlantic Current is a component of the Gulf Stream. And the Gulf Stream is a component of what's called the thermohaline conveyor. This conveyor is extremely complex. Nothing I would ever want you to remember. However, one very important part of the thermohaline conveyor is the part that the Gulf Stream's a part of. In the thermohaline conveyor, you have warm ocean water carried up from the equator up towards Europe, and it warms up much of Europe. So Iceland is very green, Europe is very green, and a lot of people live here, right? So thanks to the thermohaline conveyor, these areas are very livable. However, if you actually took a look at the latitude of most of the areas in Europe, you would notice that England, pretty much all of England, is about as far north as northern British Columbia, southern Alaska. And these regions here in Alaska are very cold year-round. And yet Europe is nice and warm. If you've ever been to London in the summertime, it can get very balmy, very hot. Much of interior Europe can get really warm in the summertime, and yet Europe is at much higher latitudes than most of North America. So, why does this happen? Well, It's because all that warm water from the Gulf Stream traveling along the thermohaline conveyor gives Europe a lot of heat. Now, with that said, the thermohaline conveyor is called the thermohaline conveyor because it relies on differences in temperature, hence the term thermo, and changes in salinity, hence the term haline. Well, there's one key component of the thermohaline conveyor, and it's here in the North Atlantic. In the North Atlantic, where heat is given off to Europe, that water then becomes very cold and salty. Once it becomes cold and salty, it sinks down into the bottom of the ocean, down to the ocean floor, and then it travels back around. This is a key component of this current. Well, in order for this water to sink, it has to be very salty. If it's not very salty, it can't sink. Well, as Greenland is melting, it's actually increasing the fresh water being dumped right into that part of the Atlantic. That's decreasing the salinity of the water, making it less salty, therefore it can't sink. If it can't sink, that shuts down this entire portion of the current. And if it shuts down this entire portion of the current, that could potentially lead to a much colder Europe. So, if the thermohaline conveyor were to shut down, it would cause abrupt cooling. If this were to happen, it could lead to many political implications and many wars. Imagine if you're living in Northern Europe and the thermohaline conveyor shuts down. Your main source of heat is gone. Suddenly, winters become unbearably harsh. Summers stay cold. Can't live there anymore, can't grow anything. Have to move away. So you move to Southern Europe. Well, are Southern Europeans going to be welcoming? Probably not. So this leads to major wars, major implications, major wars. This could be a big issue. Now here's the scary thing, going all the way back to the beginning of this lecture, going all the way back to the beginning of this module, I mentioned that there was a region in the North Atlantic that was actually cooling. That's exactly where the thermohaline conveyor is. And as it's cooling, scientists are alarmed and they're worried that it might be cooling because the thermohaline conveyor is shutting down. As I mentioned, this could have major political implications. And it could make much of Europe uninhabitable. Now, the last thing I'm going to talk about in the next lecture is